When a car is in a high-speed accident, the impact bends the frame, or unibody. Modern cars are designed to collapse in predetermined ways, absorbing the energy of the collision and protecting the occupants. When a car enters the shop, it must be carefully evaluated to determine the extent of the damage and the cost of repairing it. The repair estimate must include not only the repairs necessary to restore the vehicle's appearance, but also those essential to restoring its structural strength. In this program, you're going to learn how to analyze major collision damage to a vehicle, determine the direction of impact and the extent of the damage, develop a repair plan, and learn how to write an estimate. So what do you do when one of these vehicles is pulled into your shop? Well, first, determine what type of frame construction the vehicle has. Find the point of impact. Determine the direction and force of impact. Inspect the damage to the parts along the path of impact to a point where there's no longer any evidence of damage. Measure the vehicle's major parts and dimensions using a tram and centering gauge. We'll take a closer look at these tools in a moment. Compare the actual measurements with values in a body dimensions chart. And check the suspension and overall body damage with the proper fixtures. Before beginning any work, it's important to keep these safety tips in mind. Check for broken glass and sharp metal edges. Tape or grind them if necessary. Wipe up any leaking fluids to prevent slips. Remove the gas tank before welding or cutting. Finally, disconnect the battery to prevent a possible charge and to protect the electrical system. There are two basic types of auto body construction: body over frame and unibody vehicles. There's also a variation on the unibody called the space frame. In body over frame, the frame provides the basic structure for the vehicle and supports most of the drivetrain and mechanical accessories. Examples of body over frame vehicles include pickup trucks and many SUVs. The steel panels of a body over frame vehicle are mostly cosmetic. Damage to these vehicles can be either cosmetic or structural, but not necessarily both. Unibody is the most common type of construction in today's vehicles. Most sedans and minivans are built with unibody construction. With a unibody, the metal body panels are welded together, creating a single structural unit. Unibody sections are also designed to collapse in a collision, absorbing the impact and protecting the vehicle's occupants. Damage to a unibody vehicle usually results in both cosmetic and structural damage. For more information on the differences between these vehicles, take a look at Program 2 in the series. Determining damage to a vehicle begins by understanding how the collision occurred. Speak with the estimator or the person involved in the accident to find out. There are two types of damage to look for: direct and indirect. Direct damage is the obvious damage, or the impact zone. However, most damage that occurs in vehicles is indirect or hidden. To determine indirect damage, it's helpful to know the type and size of the vehicles involved in the accident, the speed of the vehicle at the time of impact, and the angle and direction of travel at the time of impact. This information is usually part of the accident report and is often transferred to the repair estimate. A good body technician can determine what actually happened to cause the damage. Certain damage occurs in similar patterns and sequences. There are 5 basic categories. Side sway damage occurs from side impacts. It often causes side bending of the frame or unibody. Side sway can be recognized by buckles on the impact side and a gap on the opposite side. Sag damage is a condition in which a section of the frame or unibody is lower than normal. Sag is usually caused by a direct impact in the front or rear of the vehicle and can usually be detected by a gap between the fender and door that narrows toward the top. Mash damage means that any one section of the car is shorter than factory specifications. Mash is generally limited to the front or rear of the vehicle. It can be identified by severe distortion of the bumpers, tail lights, quarter panels, floor pan, and trunk lid. Diamond damage occurs when a collision point is in line with the end of one of the side rails. The impact pushes it back, causing the frame or unibody to be pushed out of square. Twist damage is a condition in which one corner of the vehicle is higher than another. It's detected by a low or sagging corner, as if the suspension were broken. Here are the typical effects of damage to a unibody vehicle. Frontal unibody damage results from a head-on collision. In minor impacts, the bumper and frame horns are pushed back. As the collision force increases, the side rails and radiator core support are involved. With greater impact, the fender will contact the doors. The front cross members may buckle, or the body pillar will bend and drop the doors down. Rear unibody damage starts at the bumper, moves to the back panel, trunk lid, and floor pan. If the force is greater, it'll affect the quarter panels or even the pillar. Side unibody damage will cause the door, front section, center body pillar, and even the floor to deform. Energy from top impacts can be absorbed into the roof panel, roof side rail, body pillars, and quarter panels. But before any repairs can be made, measurement is critical. A tape measure or tram bar can be used to make most measurements. A tram bar is a measuring rod with two adjustable pointers attached to it. The pointers adjust for height and length. A tape measure or tram bar measures one dimension at a time and must be cross-checked using additional reference points. The best areas to select for tram bar measurements are attachment points for the suspension and mechanical parts. These points are critical to alignment. Reference point holes are frequently larger than the tip of the tram bar. To measure accurately, place the point in the holes from edge to edge. To find the center measurement, measure from the inside edge to the other inside edge. Then measure from the outside edge to the outside edge. Add these measurements together and divide by 2 to get a center measurement. Point-to-point measurement refers to the shortest distance between 2 points. Datum measurement refers to the measurement taken with the tram gauge. A datum line is an imaginary flat surface parallel to the underside of the vehicle. It's the line from which all vertical height is measured. The other imaginary reference point is the center line. The center line divides the car in half, giving you a driver's side and a passenger side. Use a body dimension manual for reference in measuring with the tram. This manual will give you measurements to key points. Also use a data chart to record your measurements. You'll need to record the location of what's being measured, the manufacturer's specifications, and your measurements. You'll also use it as a reference when straightening the vehicle's frame. Some tips when using a tram are: measure the longest points rather than shorter points. Use diagonal measurements when possible. Always check measurements against 2 or more reference points. Self-centering gauges show alignment by projecting points on the vehicle structure into the technician's line of sight. Self-centering gauges are installed at various control areas on the bottom of the vehicle. They're used in sets of 4 or more to establish the vehicle centerline and datum plane. A body manual will give information for adjusting them to hang on the same plane under the vehicle. Scales are provided for adjusting the gauges to hang at the correct distance under the vehicle. Attach 4 or 5 gauges at control points along the entire length of the car. Hang at least one of the gauges at the point of obvious damage. After all the gauges have been hung correctly, stand directly in the middle of the vehicle. Scan the centering pins with both eyes to make sure they're in line. Pins that are not in line indicate frame damage. The further you stand from the gauges, the more accurate your assessment will be. Also, look across the full width of the car to see if the gauges are parallel. The first damage condition to look for is twist. Twist exists when one side of the vehicle is pushed low or high on one end and moves in the opposite direction on the other end. It's the last condition to occur and should be the first measured. If twist damage is present, the gauges will not be parallel. Sag is a condition in which one part of the frame or unibody is lower than normal. Sag damage will show up when one gauge is lower than the others. Side sway damage exists when the front, center, or rear portion of the vehicle is out of lateral alignment. If a centering pin on any single gauge doesn't line up, then side sway damage is present. Once you learn the basics of analyzing damage to a vehicle, you know what to look for. When it comes to repairing this damage, there are a lot of repair options. One thing you'll always need to determine is whether the damaged part should be repaired or replaced. Experience will be your biggest asset in making this determination. Many times it comes down to a judgment call. Here's some guidelines to help you make those repair or replacement decisions. First, if damage is located near a stress area, such as an engine or steering mount, then replacement is required. If the metal is kinked or tightly folded rather than bent or dented, then replace it. If the time cost needed to make a repair exceeds the cost of a replacement, here again, replace it. If the damage is located directly within a crush zone, then again replacement is required. When making structural repairs to a unibody vehicle, you need to know different repair methods and how to work with various tools. There are many tools available, and your choice will depend on the location of the damage, the method you choose for repairs, and the cleanliness required. Plasma cutters work by ionizing the metal rather than oxidizing it. This means that they use a strong electromagnetic field as well as heat to weaken the molecular bonds holding the metal together, and they use high-pressure air to blow that metal out of the gap. The advantage of the plasma cutter is that it'll cut nearly any metal and can make intricate cuts. The downside is that it'll leave a hamster-nibbled edge that needs filing, grinding, and smoothing. An air cutoff tool is a good choice for plastics, fiberglass, composite materials, and sheet metal work. It's the most commonly used tool for almost all cutting applications and is the preferred tool for making nice, clean cuts. Reciprocating saws are saw blades that are driven by an air or electric motor. They're a good choice for cutting off corroded bolts and some light frame applications. A spot weld cutter is a tool designed specifically for removing spot welds in body panels. It's basically a specialized drill bit. A spot weld cutter cuts just around the area of the weld. Because it avoids the original weld, it's extremely efficient and can save a lot of time when removing panel assemblies. Once a panel is free, all that has to be done is to grind down the original spot welds. Then there's the air chisel. The air chisel is ideal for heavy-duty cutting, shearing, punching, chiseling, and breaking joints. However, in inexperienced hands, this tool can do more damage than good. It takes an experienced technician to accurately calculate the cost of repairs. By understanding the fundamental forces of a crash and how they affect different body types and construction, you'll gain a solid base for understanding damage. However, it's only through careful measurement that the full extent of damage can be determined. You must also understand what it takes to repair that damage in hours of labor as well as parts and materials. Starting from the outside of a vehicle and working inward, list everything on paper that's bent, broken, crushed, or missing. Next to each item, list the needed repairs or replacements. Collision estimating guides or crash books are a helpful aid when it comes to estimating. A crash book contains illustrated part breakouts, part names, numbers and prices, flat rate repair times, and other useful information. But crash books should never be used to determine absolute price. Instead, they should be used as a reference for pricing parts and in estimating the time required to replace them. Some terms found in the crash book that you'll need to be familiar with are R&I for remove and install, R&R for remove and replace, overhaul for remove, take apart, clean, inspect, and to reassemble, installing, replacing, and adjusting parts as needed, D&R for disconnect and reconnect. Included operations are those that can be performed individually but are also part of another operation. Overlap occurs when replacement of one part duplicates some labor operation required to replace an adjacent part. In your repair plan and estimate, you want to eliminate overlap as much as possible. With the crash book as your guide, you can get a fairly accurate idea of the time involved to repair the damage. But don't rely on the part prices in the crash book. Call and find out what parts will actually cost. It's important that your estimate be accurate. If it's too high, the insurance companies will often go with the lower estimate. If it's too low, you could be stuck with a lot of extra time and materials you're not getting paid for. Other factors to consider when writing an estimate are the time needed to set up the vehicle on a frame machine and diagnose the damage, the time needed to straighten the frame and to cut out damaged parts, the time needed to align parts, time needed to remove tar, grease, and undercoatings, time needed to free up rusted and frozen parts, time needed for drilling and plugging holes, time needed to check suspension and steering alignment, time needed to rebuild or recondition used or aftermarket parts, and the time needed to replace any damaged accessories. The crash book explains what labor time does and does not include. For example, in the crash book, replacing a fender includes removing, installing, and aligning, but it doesn't include installation of antennas, pinstriping, or application of decals. That's why the labor reported in crash books should only be used as a guide when estimating total repair costs for a vehicle. Refinishing time must also be factored into your estimate. Flat rate manuals list a labor time and materials allowance for many refinishing operations. Once all the parts and labor times for all repairs have been entered on an estimate, you can convert labor time into dollars and add it all up. Then add on any wrecker fees, storage fees, and tax to get the grand total. Make at least 3 copies of the estimate, one for the shop, one for the insurance company, and one for the customer. An estimate is considered a firm bid. Once it's signed by the owner or insurance appraiser, it's considered an authorization to complete the repair work. So, take your time. Use the methods we've outlined here and be very accurate. Now you know a little about assessing vehicle damage. You've learned how to determine the direction and force of impact and check for hidden damage. You've learned to estimate the nature and extent of frame damage by taking measurements and comparing them to factory specifications. You've seen how to use crash books and guidelines to develop the most cost-effective methods for repairing a damaged vehicle. And finally, you've learned how to write up the repair in the form of an estimate. Those are the basics for determining vehicle damage and repair requirements. Remember, hidden damage can only be discovered through careful evaluation and measurement, but the experience you gain from actually working on repairs, that's your greatest asset.